All right, so continuing on in our adventures in ionic bonding. That's the word I'm looking for. Uh, Last time we looked at determining the chemical formulas for ionic compounds. Today we're going to look at naming these things. So for instance, if we wanted to look at sodium chloride quick, I'll do it right here. Table salt, we know its chemical formula is NaCl. We can even check to make sure we learned that right. Sodium has a charge of positive 1, chlorine has a charge of negative 1. Crisscross those two, one of each, that's what we got. And we call that, if I wanted to name it, sodium chloride. All right, a couple important things here that I'm going to point out. Number one, lowercase, lowercase. Essentially, unless you're starting a sentence with the name of one of these chemicals, all lowercases, all right? It's really important, especially when you start answering some of these, like if I just ask for a name, you'd maybe capitalize the sodium, but you would never capitalize the chloride. Also, keep in mind, chemical formulas, capital letter, little letter, capital letter, little letter. Like if you went capital N, capital A, capital C, capital L, I'd have no idea what you're talking about. I'd assume that you're talking about something with nitrogen, carbon, and like two made up elements. All right. So by using lowercase and keep one other thing, if I do a uppercase I like iodine, I'd make it like that, just so we can tell the difference. All right. Sodium chloride. First thing, lowercase, lowercase. The second thing, the metal, the positive ion, always goes first. Okay. That's always true for all of these ionic compounds. Positive always goes first. Okay, kind of our first rule for naming ionic compounds. Second rule. So that means number one, positive goes first. Number two, whatever our negative ion is, that's going to go last. Okay, let's put parentheses around these. All right, negative thing always goes last. So sodium we said was positive. I can even go through and figure it out. Negative one. All right, positive one. The third step, if you notice, I didn't call this sodium chlorine, even though this is sodium, this is chlorine. When we name these, so long as our negative ion is a single atom, so in this case, or like even what we're going to say, if it's just a basic element, we have to change its name. So we're going to change the negative atom to, it's essentially just going to end with IDE. So chlorine becomes chloride, fluorine becomes fluoride, oxygen oxide, that one should be familiar. Sulfur sulfide, phosphorus phosphide, nitrogen nitride, bromine bromide. Iodine gets kind of cool, it's iodide. But yeah, so those are kind of the three rules we're going to use for naming all of these. All right, so let's name this right here. First rule we're going to use, name the positive ion first. Lithium is right here. So lithium's, there you go. I don't know why you're not, huh? My mouse doesn't like to move down there, huh? All right, well that's interesting. Um, so lithium is in column 1 if you find on your periodic table. That will form the positive charge. So lithium is positive. Fluorine, if we find it kind of directly beneath my mouse here, that's going to have a charge of -1. Step 1, name the positive ion first. Lithium, the metals get to stay lithium. Step 2, name the negative ion second. So we have fluoride. I'm sorry, fluorine. I'm skipping ahead. The third rule, change the negative atom, fluorine, so that it name ends with IDE. So let's make that a D. Fluoride. I probably should have just erased it, but that's all right. Pretty easy. All right, scroll down here. MgF2. First step, name the metal. Name the positive ion. Magnesium. Second step, name the nonmetal. Oh, I messed up. So we have fluorine again. Second step, change it so it ends with IDE. This time it will. So rather than ending it with fluorine, I'm ending it fluoride. Essentially, by changing it to IDE, I know the name has ended. I'm not dealing with anything else. One more, can't see the rules. All right, step 1, name the positive atom. So in this case, aluminum is here. Oxygen is kind of right beneath my mouse cursor there. Aluminum's positive 3. Oxygen is negative 2. Pretend that's been there the whole time. All right. So in this case, aluminum's the positive, or if you prefer, aluminium. I don't mind the British way of pronouncing it. Second step, name the nonmetal, oxygen. Third step, change it so it ends with IDE. So oxygen, I'm actually going to get rid of like the whole thing. Oxygen becomes oxide. If you've heard of iron oxide, we typically call that rust. The oxide just means there's oxygen in there. That's naming. I could work backwards too. Like if I had sodium sulfide. So in this case, I know that this is my positive, this is my negative. Sodium, find on the periodic table. It's below my mouse cursor there. It's Na. Sulfur, over here it's an S. Now I would just do sodium forms a charge of positive 1. Sulfur is negative 2. Crisscross. Na2S. The thing with the naming ionic compounds is we don't incorporate the numbers of things into the names. Because since we have our periodic tables, we can find the charges. We can figure out what the formula is. We just need to know what's in it. So sodium sulfide, I could figure it out using my periodic table, just what that compound looks like. And since we're using kind of the basic elements, if they're in the columns we numbered, so 1, 2, 3, 4, 5, 6, 7, and 8, by using those, we can figure out what charge they have. Next time, we're going to be looking at those metals that can have more than one charge, in which case figuring out the chemical formula is pretty easy because you'll typically always be given the charge. Naming them just has an extra wrinkle involved, but don't worry about that for now. Worry about that tomorrow. All right, with that, good luck with the practice.